In this video, we're going to learn how to convert between degrees and radians. Now, an entire circle equals 360 degrees. In radians, that's equal to 2 pi. Since these two measurements equal each other, we can use their ratios in a proportion, and we can use that proportion to solve for one or the other. So if we want to solve for degrees, we cross multiply and solve. We end up with radians times pi over 180. If we use the same proportion to solve for radians, and we cross multiply and solve, we'll get degrees times 180 over pi. So if you notice, the pi over 180 are just flipped. So now you have two choices for converting between the two. You can either use a proportion every time, or you can use the formulas, which acts as a shortcut. Let's see some examples using the formula.
So on the left-hand side, we have 3 different degrees that we need to convert to radians. In order to do that, we're going to multiply by pi over 180. That gives us 30 pi over 180, which reduces to 1 pi over 6, or just pi over 6. When we do 60 degrees times pi over 180, we get 60 pi over 180, and that reduces to 1 pi over 3, or just pi over 3 radians. For 120 degrees, we multiply by pi over 180, and that gives us 120 pi over 180. That reduces to 2 pi over 3. Now I want to add one more example, which is 315 degrees. If we multiply that by pi over 180, we end up with 315 pi over 180, and that reduces to 7 pi over 4, which is an improper fraction, but that's okay. Radians are written as an improper fraction, so we can leave it just like that. Now on the right-hand side here, we have 3 radian measures that we need to convert to degrees. So we flip the rule and do 180 over pi. Now, the way I remember to use this one for finding degrees is the pi has to be in the denominator in order for the 2 pi's to cancel out, which we need in order to get back to degrees. So with the pi's canceling, we're left with just 180 divided by 4, which is 45 degrees. So for 3 pi over 4, we multiply by 180 over pi. The pi's cancel, and we're left with 3 times 180 divided by 4, which is 135 degrees. And finally, 5 pi over 3. If we multiply that by 180 over pi, and the pi's cancel, we have 5 times 180 divided by 3, which is 300 degrees. So as you can see, the rule just flips depending on what we need to find. For radians, you're just simplifying your fraction and pi always remains on top. So that's how I remember that it always needs to be pi over 180 because pi is always on top. And for degrees, pi needs to be on the bottom in order to cancel the pi's out to get back to degrees.